Okay, let's get working. Uh, how our debugger will work is it will be a command line utility, and we will run our program primarily in two ways. The first way would be to pass it a process ID, and then it will be able to debug that process. The other way would be to give it a process name, and in this case our utility will actually will spin up a new process with this will be actually the path of the executable that we want to run and then debug it. So it will spin up a new process with that executable. uh, Let me say path.exe, path to that executable. It will spin up a process with it and then debug it. So in any case, we want to when we want to debug something, we want to be able to run ptrace command on it. So we will do that. The the first thing we need to do is handle the command line arguments. I told you we'll be running uh, all of this via command line utility. So we need to handle the command line arguments. To do that in Rust, let args equal to hmm, env args dot collect. What type annotation needed? A vec of string. It's going to be a vec of string, and the first argument to any Rust program is the path of the target itself, of the target binary of our Rust program itself. So this creates a binary for us when we build this project, and the first argument is always going to be the path to that binary. So we want the argument length to not be equal to 1. If it is equal to 1, in that case, we didn't execute our program with either of those options. We didn't pass in a PID, or we didn't give it a path to a exe. In that case, I want to shut down the process. So if args dot len equal to 1, in that case I want to print line, give a process ID to attach to process ID, or binary path, and I want to process exit in this case. Otherwise I want to attach to a process, and maybe we need to spin up a process, so I'll create a method for that, and it will return a bit option. So it will be an option of I32, and I will send in the args to it. So let me create this method with function control X. So I want it to be in utility, so I'll create a process file, and let's make it pub. Let's go back to main. What's the issue? Pub fn. What's the issue? Why is it not importing? Import. Sorry. Use our That's the issue. Imported and args. The two options that I told are these. So for instead of option, let me make it a result. Because in that case, I can return an error as well. So uh, error message. Uh-huh. For now. So these are the two options. I told you the first argument is always going to be the part of the binary. So this will be the second argument and this will be the third argument. In this case, the length of args must be equal to 3. So if args dot len is equal to 3 and args of 1 equal to minus p, in that case, uh, we want to attach to an existing process. Otherwise, I want to spin up a new process and attach to it. So we want to attach to an existing process, and we have the process ID, the target process ID we want to attach to. So let me tell you what I mean by process IDs. So these IDs you see, these are the process IDs for any program running on Linux. You'll have a process ID. So if you want to debug Postgres, then you want to send this process ID into our code that we are writing as a runtime argument. And how do we do that is cargo run minus p and then the process ID. Let's say 232. This is how you're going to run the program. Cargo run and then runtime arguments. So let it equal to, this is going to be args of 2 and this is a string right now, but I want an integer, an I32. So dot parse into I32. If this doesn't work, I want to quit. So map error, and I don't want to do anything with the error. I just want to say invalid PID, not a valid number. Otherwise, if PID is less than 0, in that case also invalid PID. It is a result. Args.parse gives a result. So question mark. So if PID is less than equal to 0, in that case I want to return an error. This is why I wanted to use a result instead of option. And invalid PID Must be positive and then dot toString. Does this not need to be a toString as well? It takes both. That's fine. If the control comes here, that means the process ID is valid. So we can attach to it with the ptrace. Uh, ptrace. It's not coming up. Let me see why. So to import it, unresolved cargo.toml, but I have it already. Ah, so stupid. It's not cargo.toml, it's config.toml. Config.toml, and now we can refresh it. And let's delete target. Let's delete clock. Let's open the terminal. Let's go to WSL. Let's do a cargo build. Build fine. Now it's not giving the error. So let's try to attach now. Now we can attach by passing in the PID. And let's import PID from, yeah, this is fine. PID from raw, and I will pass in the PID to it. And let me just OK off PID. OK off PID. And we can map error. It takes an error, and let's format to attach, and let's pass in the error. Format error now, and unused result. So let me unwrap it. Okay, that's fine. So what it does is we convert the string to an integer PID. I check if it's positive, and if it's positive, I attach to it using syscall ptrace, and then just return the PID. If that is not the case, if the control ever comes into else, we want to spin up a new process, and in that process, I want to attach to that new process, like we're attaching to an existing process. Now, in here, I would want to attach to a process that we spin up. So, like I told you, we are going to send in a path. So, let program path equal to args of 1. 0 is going to be the R code's binary. Now it's going to be, so we want to spin up a new process. How that happens is we fork the current process that creates two processes, a parent and a child, and in that child process, I will execute a new process. So that will replace the process in the child process. So that's how we're going to do it. Now, to fork the current process, we use fork. Uh, Now this fork can only be used inside an unsafe block because it's unsafe code. So fork, let fork uh, result equal to this, and fork res, and let's match on fork res. uh, Patterns. Okay, so if you were to ever go into fork res, you will see that fork result has two options, child and parent. So we'll add an OK for both of them. So for result parent and takes a child, and here I'll have a fork result of child. The child in here is essentially the PID. So let PID equals to child dot asraw, and let's just print something. Uh, Maybe we don't even need to print. So OK of PID. So in here as well, I want to return an error. So this error is going to be format, and inside of the format I will just say fork failed, and it's taken the error. And let's just why is it throwing this unused result must be used? Oh, okay, bad yaar. That's what causing this warning. Huh. Okay, so right here we return the error. Otherwise, in here, so this is unsafe, and else here. So how this match will work is both of these code blocks will be executed, but this will be executed in the parent process and this will be executed in the child process. So in the child process, we want to replace the current process's memory with a new program. We want to load a new program into it, and that will be the program that we want to debug. That's our target program, and it will have the same process ID as the child, and it will have the same parent process as the child. All of that can be achieved with exec, and we also want this new process to be debuggable, and we are doing that by attaching to it using ptrace. Ptrace attach. Ptrace has another method for us called trace me, so that attaches to the current process, that makes the current process debuggable. So we will use that in here. So let me do that actually. P trace of trace me, and it returns something. Let trace me res. It returns a result. Okay. So now that result may error out. In that case, if let error equals to trace me result, in that case I want to ePrint line tracing child process failed. Let's just print what the error is. And I just want to exit out of the current program. I can do that with process of exit and import. But if that is not the case, if we are able to trace the current process, I want to replace the current process with the new program that we are passing into our debugger. So uh, we do that using exec exec vp right here. So this exec vp, it takes two arguments. One is the process, and then its arguments takes cchar. So that will be the path of the program that we want to execute, and then the arguments. Now, like any C++ or a Rust binary, the first argument to any process is the path of the binary itself. So we will pass the path of the binary as the arguments to it. So now this exec CVP expects a C string. A C string is essentially just strings that are compatible with C code. Why is that? Because uh, it's actually a syscall written in C, right? We're just invoking it in Rust code. So we want to pass in strings to it that are compatible with C code. And we can do that in Rust using C strings. So we have this program path, right? I want to convert it into a string that is compatible with C, because strings in Rust are UTF-8. So that's not how it is in C. Let program path C equal to C string C string new. Do we have it? Yeah, we do. And then program path. So it also is a result, right? So let's just say expect C string conversion failed. And I told you, for arguments we will just pass in uh, an array of length 1, and it will only include the path of the binary that we are executing. The same logic I told you right here, like the first argument in this vector will be the path of the binary that we are executing itself, the path of this code compiled. So similarly, we will pass in the same path as argument to this one. So let exec args equal to, and it's going to be a vec. So I'll use this macro, and I will program path C and clone because I want to use it as well. And then I will send in a reference of program path C and a reference of exec args. Am I importing it from the wrong place? Exec, yeah, I don't want to import it from. I want to import it from. Remove this. Where do I want to import it from? I want to import it not from libc, from here. Let exec the result of infallible. Huh. So it may error out, right? If let error e of, let's make it exec error. If we error out, I want to e print line exec failed and process exit with one expected result but found nothing because when we execute a new process, when we exec this, control will only come here in case of error, and in case of error we are exiting out of the current program. When we when we replace the process with this new program, control will never come here if that program works successfully. So let's just mark it as unreachable. Let's try to build this code. Cargo clean, cargo build. Could not compile RDB to do R1 dot clone. Where is it? Huh? Error in move occurs here because okay. Does this work? What's the error? Consider borrowing here. Consider cloning the value. Move occurs here because value has type string, which does not implement copy iterate. So let me just clone it then. Let's try to build it. Built fine. So now our attach method is completed. Let's go back to main, and here we get this result. So, but we're not doing anything with it. Uh, what we want to do is when the code comes in this branch, where is it? Whenever the code comes in this branch, in this else block, we are spinning up a new process. Now this spinning up of a new process may take some time, so we don't want to immediately start debugging it. We don't want to immediately start interacting with it. So we want to wait for it to either complete spinning up or to crash. So we want to wait, and we have the PID, and we can wait for a process using a PID using wait PID, which is another syscall. So let wait is equals to wait PID, and let's import it from this wait or yeah this wait PID, and from bro, and I will send in the PID. PID is also a result, right? So here there may have been an error, so let PID equals to match of PID let's just say ls return p, and in case of error, I want to be print line and exit out in case of error. Wait result, wait pid, and I can pass in pid to it now. What else does it expect? Two arguments, fill missing argument, and none is fine for now. So wait pid also takes some options. So those options are these. I don't know what these do now for our use case right now. None will suffice. We don't want to pass any specific options. We just want to wait for this bid. So let's match on this wait result, and in case of error again, wait bid failed. So let me just copy this. Wait bid failed. And now if waiting is successful, we can right here start interacting with that new process or the process that we have attached to. We will do that in the next video, and that's it for this one. I'll see you in the next one. Bye bye.